Hello student, myself Imranullah Khan, Assistant Professor, Department of Computer Science and Engineering, Sri Krishna Institute of Technology, Bangalore. Student, today I am going to show you how to simulate the second lab experiment of ADE lab. Okay, that is Relaxation Oscillator. Using UA741 operational amplifier IC, design a 1 kHz relaxation oscillator with 50% duty cycle and simulate the same. So design part I have already explained you. Please go through that, or the link also there in the description. Please watch that video for the design part of this experiment. Now today I'll show you how to simulate this circuit diagram by using the PSpice software. Again, the installation of PSpice software also I have showed you people. Okay. Now open the PSpice software which you have already installed. If you have any doubt in the installation, please watch my video. We can easily install it. Okay. So after after opening the software, go to File, select New Project. Okay, select New and New Project. Here it will ask you to give the project name. Give anything. I'll give PRG program 2. Program 2 I'll give. Okay, then you have to select analog or mixed AD. Analog or mixed AD, you have to select it by default. When you newly install, you will get this semantic will be selected by default. You have to change it to analog or mixed AD and give the file name, and path also you have to select path. Any path you can select, browse it, create one folder wherever you want, either in desktop or any drive. So I recommend you to create one folder and save all your project into that folder. You can easily watch it later. Okay. Now for time being, I'll keep in the default location, that is in the C drive, program files, or Catlight, the name of the PSpice software. Okay. Then I'll click OK. Then it will ask you to create the existing project, modify the existing project, or create a new project. I'll take create a blank project. Click OK. So this is the area where you have to place all the components, and you have to make a circuit. Okay. Now to get the components, here you can see the right hand side there are some shortcut. Place in the part you will find all the libraries and all the components. Okay, that also you can do it. Now which component we want, that is depend upon your circuit diagram. Now here we have the circuit diagram of relaxation oscillator. So this is the circuit diagram. We need one IC, that is operational amplifier IC. We need the 3 resistors here. We need capacitor. Okay. We want source, that is VDC, to supply the plus 12 and minus 12 value. Okay. These are the component we required. First thing is you should have the circuit diagram with you people. Circuit diagram should be ready, and it's what are the components you want and what are the names of those components, because we have to search with that name in our simulation board, simulation libraries. Okay. Then go to the after taking the circuit diagram, go back to your simulation workplace, then go to place, then click on part. Okay, here so many libraries are there. You can see so many libraries are there. Okay, in each library the developer have placed different components. Here so many libraries are there. Each library contains a different component. So you should know what is the name of this component and that component present in which directory. Okay. If you don't know it, also I'll tell you how to find that the component. For example, we want one IC. So the name of this IC is UA741. UA741. You just type here UA741, and see this UA741 is not there in ABM library. Then check it out. It may be in analog, it may be in analog P, breakthrough, or design cache, eval. Yes, it is there in eval. Okay. So like this also you can search one by one, or if you know the library, just select that library, give the name of the component, Just type name of the component, you will get that component preview here. Check it out, is this the component you required? If it is, click OK and place it wherever you want. Now we want IC, go to eval, just type the name of the IC, UA741. So this is the IC we want, click OK, then place it here, and we want one, or if you want one more, place it how many you want. Okay, and if you don't want, if you want to end that mode, right click, end mode. You can see your cursor, the mouse cursor will become normal cursor. Okay, and by mistakenly if you have placed the extra component, you can remove it. Just select it, click delete button, select it, click the delete button. Okay, so this is the IC we want it. But you see the circuit diagram here, pin number 2 is up, pin number 3 is down. Here you see pin number 3 is up, pin number 2 is down. You can change it, or you can redraw your circuit diagram based on this, or you can change this, make it mirror vertical, then pin number 2 will go up and pin number 3 will come down. So this is the IC we want, correct? Now we want 3 resistor. For that, go to place again, take part, click on part. In the analog library you will find the resistor, just type R. Yes, this is the resistor we want, click it, place it here. One we want here, one we want here, right click, rotate, and one we want in this fashion, so I'll place here. Right click, end mode, 3 resistor, I got it. Now I want capacitor, go to place, click on part, go to in the analog itself, just type C, you will get the capacitor, rotate it, place somewhere here, then right click, end mode. Then okay, the first thing is, student, remember you should have software with you should have circuit diagram. Then based on the circuit diagram, first thing is you have to place the components. Now we have placed the component based on our circuit diagram. Based on our circuit diagram, we have placed the component. Now we have to give the connection. To give connection, you have to take place wire. Place a wire. This is the place wire, and the thick one is place bus. Don't take place bus. Take it to place a wire. And see the circuit diagram. Based on the circuit diagram, you give the connection. There is a connection between pin number 2 and pin number 6. Sorry, pin number 6 and this resistor. There is a connection. Give the connection. Pin number 6 and pin number one end of the resistor. The other end of the resistor should go to capacitor one end. See, while connecting, you should be very, very careful until you find the red dot. You have to stop it. Once you find the red dot, you have to stop it. And again pin number 2 and connect like this until you find the red dot. If you don't stop, if you further continue, see the warning symbol you will get, this is wrong. You will not get the output. Go back and stop it. Again here same thing, pin number 3 is connected. See, this is wrong. You cannot, your wire cannot pass through the component. It should stop in that square box. Okay, and here also same thing, drag it, stop it from this end of the resistor to pin number 6. Now this completes our circuit diagram. You just see here, according to circuit diagram, we have given the connection. Now second thing is, first is placing the component, second thing is giving the connection, third thing is, third point what you have to remember is changing the values. You have to change the values of the component. Okay, see this R1, you can say no, this is the name of the component, and this 1K whatever you're saying, this is the value of the component. Just click on this, and based on the design, whatever values we got, based on our design, those values you have to place here. From our design we got this is 5K, change it to 5K and give it. So here the R2 and R2 is equal to R3. So this from the design we got this. Double click on this, give 10K. This the value of this R2 is 10K and R3 also 10K. Okay. Now the capacitor value is 0.1 microfarad. 0.1 microfarad, that is 0.1 UF microfarad. UF. Okay. After this, here you can see this pin number 7 and pin number 4 should be connected to VCC. Student, please remember, I have told you many times, This connection is very, very important. Pin number 7 should be connected to plus 12 VCC. Pin number 4 should be connected to minus 12 VCC. If you reverse this, if you do vice versa, your IC will burn, it will damage your circuit, it will damage the components of the circuit. So you should be very, very careful. Okay. Now to get the source to supply that plus 12 and minus 12, the name of that source is VDC. Go to place part in the source library, just type VDC, you will get that source. This is the source we wanted. Click OK. Plus 12 and should be connected to pin number 7, minus should be connected to pin number 4 end mode. Okay, now change the value 0. By default, you will get 0 volt, make it 12 volt. Down also, you change it to 12 volts. Okay. Now, the values also we have changed. Now, next is we have to connect the ground. The ground shortcut is here, or you go to place. Okay, here you can find the ground. The shortcut is Control G also. So this is the ground. Go to source. In the source, see 3 libraries again. Go to source library, then select the 0 value. Okay, connect one ground here. This is again based on your circuit diagram. Connect one ground here, connect one ground, and you have to connect ground here. Rotate 2 times so that we can connect it easily. Okay, then connect like this. Okay, end mode. We have connected the ground. Now next is after giving the values, connecting the ground, go to save it, save your circuit. Go to PSpice, click on new simulation profile. When you click on new simulation profile, give some name here, any name you can give. Click on create. Once you click on create, one window will open that you can find it in the taskbar. Open it. Here you have to give the run to time and maximum step size. Run to time and maximum step size that is there in the manual I have given. Just check it out. The run to time is 10 millisecond, 10 millisecond, and maximum step size is 0.01 millisecond. You can change this based on the requirement, how the waveform you want. Based on that, you can change these values as well. Okay, 10 millisecond and 0.01 millisecond. Click on apply, click on OK. Then if you want to see the output, you have to connect the voltage level marker. Where you get the voltage level marker? Here you can see the shortcut V symbol. Just select this voltage level marker. Now there are 2 types of waveform we will get through this circuit. One is a square waveform. Okay, another one is the capacitor waveform. If you want to get the capacitor waveform, connect this voltage level marker to pin number 2. See here, pin number 2, we have connected the capacitor. No, but pin number 2 I have connected, and this is connected to pin number 6 to get the square waveform. To see the output, pin number 6, the square waveform output. End mode. Save it. Okay, then click on run. Once you click on run, the color of your circuit will change, and here in the taskbar you can find that output window. Just click. See, this is the exact output. This is the square waveform the voltage level marker that we have connected at pin number 6. For that, we are getting the square waveform, and this is the sawtooth waveform, that is the capacitor waveform. See, this is capacitor charging and again discharging, charging, discharging. Okay, this is the capacitor waveform we are getting, that we have connected to pin number 2. For that, we are getting it. Now next is I'll show you. See, input and out, this 2 output, that is the square waveform as well as the sawtooth waveform. Coming at single window, you can separate it. You can separate the capacitor waveform. You can separate the that square waveform. Okay. So how to do that? Go to plot. Okay. Add a plot. Here add plot is there. No. Add a plot to the window. One window we added here. Now after that, we have to pull this either this one, the capacitor waveform, or this one we have to pull and we have to place here in the new window. So for that, what you have to do is, one thing you observe here, the green thing, the green waveform, the waveform which is in green color is capacitor waveform. The value of that is VC1:2. The red color waveform is there, no, the value of that is VR2 is to 2. Okay, that you have to notice. Then after getting the window, one window we got it, after plotting that window, go to trace. We have to trace this value to get the waveform. Go to trace. Okay, in the add trace, search this value, which one. For example, I want to take out this capacitor waveform. What is the value of that? VC1 is to 2. Just type here V C1 is to, see here, VC1 is to 2. Just select that, click OK. Now see here, we got the capacitor waveform. Now, if you want the the square waveform, again the same thing. Go to plot, add plot to the window, then go to trace, add trace. In that again, what is the value? VR2. Just type V. Okay, here it is. VR2 is to 2. VR2 is to 2. Select this. See here, we got the square waveform. This is how student, you can separate the waveform as well. This is the exact output, that is square waveform and sawtooth waveform. When you will get this, when your circuit diagram is correct, if you don't have any mistake in the circuit diagram, those warning I showed you, right, you have to stop until you find the red dot. If you further if you move ahead, you will get the warning. If you continue with that warning, you will not get the output. You will not get the exact output sometime, and you will not get the output at all. Okay, very difficult to debug. At that time, what you have to do, you have to remove all these wires. You have to delete all these wires, and you have to reconnect it. You have to reconnect it, then again execute, and see, you will get the output. I hope you understood this. Thank you so much. Any doubt, you can message me. Thank you, student.